Hello everyone and welcome to today's webinar, Southwire's BEM software revolutionizing the electrical industry. This webinar is brought to you today by LiveLab Learning, which is a subsidiary of Academic Core, a wholly owned applied software company created to provide world-class training. And my name is Rachel Grillo, and I'm delighted to be your moderator today. Throughout our presentation, we do encourage you to interact with us by typing in questions and comments using the questions pane, and we'll be answering all the questions at the very end of the presentation. Next slide, please. There we go. This webinar is being recorded, and it will be available to you online on our YouTube channel. And we'll also send you an email following the webinar with a link to the recording. And if you haven't already, search LiveLab Learning on Facebook and like our page to receive the latest information and special offers. And when you visit our website, livelablearning.com, there's a complete list of the upcoming schedule for training. We also have a couple webinars coming up. We've got our BIM and Beer in Dallas. That's going to be on February 18th from 5:30 to 8:30 p.m. So any of you folks joining us from Dallas, we'd love to see you there. And then we also have another BIM and Beer in Miami, and that's going to be on Thursday, March 17th. Same time, 5:30 to 8:30 p.m. So again, if you'd like to join it, and if you would like an invitation, please send me an email, and I'll make sure to get that invite out to you guys. And here's our upcoming webinars. We've got our Fab Hangout, everything you need to know about Autodesk fabrication. And that's going to be on February the 25th. And then we have a BIM 360 Hangout coming up on March 10th as well. And also would like to let you guys know that following the Q&A at the end of the webinar, we will give away a $25 Visa gift card. You must be present to win the gift card, and I will pick a winner from our list of attendees. So stick around, you might be our winner. And our speaker today has been working as an electrical designer in engineering offices for the past 35 years. He met Gerald Nessler, the inventor of the CARS software, Cable and Raceway Systems, in 2004. Has been a power user creating project deliverables, primarily in the oil and gas industry, for many years. He recently joined our applied software team as the Director of Services for the Construction Technology Group. And he's a wealth of knowledge and experience to get the most productivity out of the technology tools that were presented today. And we also have Mike Massey with us. Mike has been with Applied Software for several years, and he'll be able to help us weigh in on any Revit questions that there may be today. So please join me in welcoming today's speaker, Roy Labradette.
Thank you, Rachel.
You're welcome.
Welcome to all of our participants. I'm very happy to have you joining us today. Let me minimize our PowerPoint. What we're going to do today is take a look at some of the functionality of the CARS software. We're going to focus today on our modeling. It's called Traymatic, and it will show us how we can design our raceways and locate our equipment, and then we will route some cables at the end. Now, this is a live demo, so we're actually hoping that everything goes well, but if we do have a little bit of a glitch or a surprise, that's what makes live demos so exciting. So with that said, I'm going to also mention that I'm going to work in AutoCAD. The functionality that you are going to see today is also available in Revit. The interface might be a little different, but the functionality is all going to be the same. So if the Revit users are out there and you think, oh, this is just an AutoCAD product, that's not the case. In the future, we're going to schedule a very similar presentation that's going to be Revit based, and you will be able to see firsthand the program actually work in a Revit environment. But for today, just please understand the functionality and the power of the database and the power of the program is irrelevant of the CAD platform that we're using as an output. So with that said, let's take a look first at our Traymatic menu. What you have up here is the cable tray button, and we're going to start out by picking the retrieval code. Retrieval code is essentially the voltage level, and the user gets to define the retrieval codes for all of the various components that we're going to use in our modeling. So if I pick a low voltage tray, the program is set up with a B-line aluminum ladder tray, and it's set to default to 6-inch high and 24-inch inside radius, and obviously we'll be able to change the radius on the fly if we need to. And I like to lock the size of my trays. The program has the capability to resize raceways, both cable tray and conduit, depending on the cables that actually end up routed through those raceways. But on the cable tray, I usually lock my size because I want to make sure that the designer and the engineer have control over the size of the cable tray. Conduit, it's just the opposite. I'll usually use a generic size conduit, and you can set minimum and maximum sizes on a project-by-project basis. We could also select a cover that will show up in our bill of material, and we also have the ability to put in a divider. So if you've got a tray that's going to be shared by more than one voltage level, you can put a divider in. The tray will actually consider, the program will actually consider the tray fill on either side of the divider for your multiple voltage levels. So with all that said, let's pick a width. We're going to start with a 36-inch tray, and in order to add the tray, first we'll set our AutoCAD elevation to, let's say, 10 feet. And then we'll start modeling tray. You pick the attach, and then it's very simple to just point and shoot. Put your tray in where you want it to go, and the tray spec is not set. There we go with the live demo already. We're off to a good start. Attach. Okay, let's refresh our drawing connection and try this one more time. I promise you this works very well. Oh. There we go. I was starting to worry about that a little bit myself. What I was doing is I was picking the wrong button. It was a user error. So anyway, as you can see, the tray will get modeled, and the fittings are automatically determined to, meet what was needed. Now, if we had a T instead of an elbow that was required at this point, we could just grab this node, and the program is going to convert the fitting from an elbow to a T. If we needed to change size, we pick a 24-inch tray, and we attach to this node, and the program will, I did that again. I hope it gets better. I'm usually a lot better at this. All right, we're going to pick a 24-inch tray, and we're going to add, and the program will put in our reducer and route our 24-inch tray. Now I've got a 24-inch tray spec set. If I didn't know what size this was, but I wanted to continue on this one, I could go back and do some dimensioning and try to figure out what size tray I was using, or I could hit the button that I've been trying to use all along in this presentation, the attach button, and grab this node, and in that case, the program will now reset my tray spec to match the type of the size and type of tray that we were working with. This is a 3D program. I've got a little bit of extra stuff in there. This is a 3D program, so we can work in the vertical also. It will put in vertical inside, vertical outside fittings. You can actually slope a tray. and I know that this happens to me all the time, if I needed to go at a 30-degree angle up to elevation 25 feet, I could sit here and do a lot of math, or I can just let the program do the work, and it'll put in the fitting for me, as well as calculating the angle. So it's doing a lot of the heavy lifting for me, and it allows me then to be able to see the actual angle that was generated. All right, now that we've got our tray model started, let's go back into plan view. These tray segments each have to have a unique name, so when we route our cable, we can identify the path and the route that the cable is going to take through the raceway system. We always have a choice of user tagging, and we could have put in the tray tags as we went along. I chose not to do that. I chose to just wait until I had my tray model and then let the program automatically assign my tray segment numbers. And since this is a database, the AutoCAD, the environment that we're working in, is not really storing the information. We have to save it to the database, and the program just alerted me that we needed to save after we tagged our trays. So now that our trays are tagged, we still have the availability to modify this tray. For example, this piece right here needed to be a little longer. I can use my AutoCAD stretch command or any other AutoCAD commands, and then just simply save the tray to the database again, and it updates. The nice thing about it is it's got a lot of functionality that comes with the program, but it doesn't take away any of the functionality that you have either in AutoCAD or in Revit. So in that manner, it's very user-friendly. In order to create my tray deliverable drawings, I'm going to need to dimension this, and obviously everyone knows how to dimension a drawing, so I'm not going to show you that. But we also have to identify a lot of information about the cable tray. So I'm going to go back to my tray tagging, and I'm going to assign leaders, locate the leaders. The first thing I'll need to do is to determine my drawing scale, and in this case it would be 1/4 inch equals a foot, so my scale factor would be 48. And we get this leader menu. We have annotation settings. We got lots of options on how to control our annotation to give us lots of different choices of what we want to show and what we don't. So for the purposes of this demonstration, I'm just going to go ahead and accept the defaults, and we're going to insert our leaders. Now the leaders are smart, and the text that is attached to them is read by the database and can be updated at any time, or it can be moved or manipulated or change the style of the font. All AutoCAD text commands and text functionality is still available. So I'm going to pick up and to the right to place my leaders, and you're going to see that it's going to go ahead and put these on the tray. And I'm going to pick a couple more, and then one down here after we made that elevation change. Okay, so if I zoom in on this, you'll see that the tray tags are identified, the width, the bill of material number, which we determine and decide ourselves, or you can leave that commodity code blank and the program will randomly assign one for you, and your bottom of tray elevation. As we go through the elbow, the size of the tray changes, so therefore the bill of material number needs to change. And as the tray goes through the vertical inside, vertical outside fittings, it's going to change bottom of tray elevation, and that's also indicated from the route that we decided. In addition to identifying the tray segment numbers and the bill of materials for the straight sections, we're going to have to identify the fittings as well. So we'll pick a fitting call-out leader, and this time we'll go down and to the left, and we'll place our bill of material tags on the fittings. And I'm just going to spot a few in here. So that way the program has determined the material that's needed, and we can get a bill of material on our tray. We'll do that by going back to our main menu and going to File, Bill of Material for Trays in the Drawing, and it will give us a list of all of the material that we have currently in our AutoCAD file. It's an Excel spreadsheet. Makes it very handy. Most clients ask for the material takeoff in Excel, so I'm really happy that we're able to provide it in that format. And also, if I need to put this bill of material on my AutoCAD drawing, it's very easy to copy and paste it as an OLE object into my AutoCAD deliverable drawing, and I can save it with the drawing. Now, one more thing I want to talk about in AutoCAD, when we are finished with this project, we're going to need to turn this project over to our client to put in their document control system. All of the files that we create, whether it's an Excel spreadsheet, a Word file, an AutoCAD file, or a Revit file, are all able to be saved and stored as standalone documents. The program is not required in order to open, print, and even edit those files once you've turned them over to the client. So I could save this file at any time. I could also erase this information, and since it's stored in the database, I have the ability to retrieve it from the database at any time. So I can use the database tools to retrieve my power trays. These are the retrieval codes, and we're allowed to customize the retrieval codes for the to suit the exact conditions of our project. In this particular project, I set up for separating tail end devices or termination boxes by communication, electrical, fire and gas, instrument, and lights. My conduits are separated by voltage level, high, instrument, medium, and low voltage power, and dropouts are field routes. So field routes will allow you to route cables without a physical conduit and without the restraints or fill requirements of a conduit. This happens frequently when you have like a CLX or a MCHL cable or TCER cable that's frequently routed on studs or outside of the tray system on beam supports. And finally, the cable tray, again with the various different voltage levels indicated. So let's pick our tray, our power tray, and we'll retrieve it from the database, and we get our model right back as we saved it. Now look at this in isometric view. Frequently when we're modeling cable tray, we're following the path of a pipe rack or a pipe chase or something. So we're going to have multiple levels of tray that are going to be stacked. So I could go in and reset my AutoCAD elevation and start modeling the tray as I went up. But the easy way to do it is to use the stack command. The next level up will be a medium voltage, and then the level above that will be a high voltage. And I want a 24-inch separation between my tray levels. So I hit OK, and the program is asking me to select the trays that I want to replicate, and I'm going to pick these and these. And I'm purposely not picking this one because there's a T here, and I want to show you what happens. When the program builds the tray, a T is not required in the next two levels because there is no branch. So the program knew to put in horizontal elbows for those two particular tray segments. And if I look at this in elevation, you can see that the program also did the offsets in the vertical and on the 30-degree angle. So it is very smart, very intuitive. Once I've done this, obviously I can control these levels and turn them on and off either by layer or by what I choose to retrieve from the database using my retrieval codes. Now let's go ahead and tag these trays. Auto assign those tray tag numbers. And again, it's going to set the database for me. And I'm going to flip back to plan view. It wants to do that to me, doesn't it? Okay, and I'm going to go back to my leaders. Yes. Okay. This time when I put my leaders in, I will go up and to the right, and when I tag the tray, you'll see that it's supposed to be a fitting. Sorry. Having a bad hair day today. Okay, when I go to tray leaders and I pick up and to the right and I select this tray, there are actually 3 levels of tray there. So the program knows that, and it gives you the different segment numbers for those 3 levels and also the different elevations. Now these trays are the same size, so they have the same bill of material number. If I were to tag my tray fittings, and I'll go down and to the left, and I'll pick this point. In this case, I've got 1 T and 2 elbows, and they're all stacked. So the program's telling me I have 3 components there, and they do have different bill of material numbers since they are different components. So this makes it very easy for you to get your materials and your deliverable drawings done. And obviously, since we've there we go. And obviously, since we've done this in the database, we can always get an updated bill of material. So let's go ahead and run it again. And this updated bill of material indicates the addition of the 2 more, levels of tray that we just added. Okay, now one more time I'm going to erase and retrieve power trays only. Okay. In order to route cable, we have to have the equipment located in the model. You have to have an origin and a destination and a complete raceway between the origin and destination. So the way I'll do that is I'll go to tail ends and I'll go to boxes, and these are going to be termination boxes. Termination boxes are a place where a cable is actually terminated or lands. A conduit fitting is a pull box where a cable would actually pass through, like a conduit T or a multi-cable transit in the building wall. Again, I'm going to set my retrieval code, and the program knows I'm modeling boxes now, so I get a different selection. And if I'm going to pick electrical boxes and pick new, this is a list of the equipment that we've created in our database, and in order to locate that, I'll just pick, let's pick PBA 500A and go ahead and place that somewhere in the model. When I hit new, PBA 500A now, oh shoot, hit the wrong button. Okay. PBA 500A has already been located. So it's no longer available on the list because the program knows it has a XYZ coordinate. So let's pick PBA 500B and go ahead and place that guy right here. Okay. The next thing we want to do is to put conduits from those end devices back to our cable tray system. Again, we're going to use tail ends, but this time we're going to use the conduit tab, and we're going to pick a retrieval code, and these are our choices on our conduit retrieval codes. Since these are low voltage power, we're going to pick that retrieval code, and we're going to set our size and type of our conduit. So we could come up here and say this needs to be a 4-inch EMT or a 2-inch PVC. We could force it to use a specific conduit size and type, and we could lock that conduit size. What I prefer to do is to use a generic EMT and unlock the size. This allows the program to route the cables through that raceway and then later to size the raceway and depending on what actually gets routed in it. Now we have a choice here to pick auto route to the closest tray. So if I pick route and I pick this device, it's going to put a conduit in the model to the nearest point on a cable tray. I can also route it to a pick tray, and if I use this option, I can select this device, and obviously this is the nearest tray, but I'm going to force it to route to a tray further away. For whatever reason you might want to do that, that capability exists. Okay. I could also auto route to pick points, or I could manually route the entire cable, and I have an option to set a predetermined elevation. So let me retrieve a couple of more pieces of equipment that I've already located in the model. And when I bring these pieces of equipment in, I get the XYZ coordinate, the node where the equipment is located, but I don't know what that equipment is. So I'm going to go over to Cool Tools, and I'm going to select these two pieces of equipment. And it tells me that's PAX 700A and B, so I'm going to show and tag those. And the program will give me the equipment tag and the description as it's reading it from the database, which is very handy. So I'll go back to my tail ends, and I'm going to, again, auto route my conduit, but this time I want to go up to elevation 15 feet to make sure that I'm routing it along the steel. And let's go ahead and just auto route this one, and I'll pick that one, and then pick the next one, and let it auto route that one as well. So now we've got a few pieces of conduit in the model. Now over on this side, I'm going to go back to Cool Tools and clear my screen and select, these are my two motor control centers. So in case of a motor control center, the cables are just going to drop from the motor control center straight into the tray without necessarily going through a physical conduit. So in this case, I want to be able to field route these because I don't want it to be restricted by a conduit size. So I will pick a dropout, and the dropout is the only choice here, so it defaults to dropout. And I could again route it through 15 feet, but I'm not going to do it because the cables are going to pour right into the tray system. So I'll route to the nearest tray and pick this one, and then also pick that one. So now I've got a complete raceway from my motor control centers, which I didn't tag. Show and tag. There we go. So now there's your motor control centers. I've got a complete raceway from the motor control center through the cable tray system to my end devices. So let's select these end devices again. And now we can add the cables. I'm going to pick the cables that are both routed and not routed. I'll add the cables. So there are 4 cables, one going to each one of these end devices. I need to have my Cable-Matic up and running in order to route cables, and I need to have the databases synchronized between the physical raceways in the model and the cable routing device or cable routing tool where I'm actually going to build my cable schedule and be able to get my cable takeoffs, which is Cable-Matic. So I'm going to go ahead and hide that, and I'm going to hit route. And the program will route those 4 cables for me. And then I can show how those cables actually got routed through the raceway system. Now what's really nice about this is I've got a lot of options. I can, if I wanted to query a specific cable, I could pick that cable and I could ask the program to tell me which end devices it's connecting to and what raceways it's taking or what path it's taking to get to those, from and to those end devices. I could also select a specific raceway and query it to tell me which cables are currently routed in that raceway. And then finally, I could pick a piece of equipment and get a list of the cables that are either routed or not routed. So if I pick not routed, there are no cables that are going to that are not routed. But if I pick the routed cables, I can query the cable list. So it gives me options to be able to select and find information about my model from various different sources. Okay, let's go back to our tail ends and let's take a look at these two devices down here. Let's go to Cool Tools and Clear, and let me select these two devices. These are two raceway devices. They're actually pull points. Okay, so if I wanted to route a conduit from pull point to pull point, I could do a manual route, and I could actually use my AutoCAD functionality to route my conduit, and the program will put in a conduit. Now, once this is done, I could populate it with cable. I can also modify it and using my AutoCAD commands, my grips, my stretches, and so on and so forth. Another thing that we can do, a lot of times we're going to route our conduit in a rack or through a plenum, right? So we're going to want to be able to route conduits, multiple conduits that are going to follow the same route or same path. So let me delete the one that I just drew in there and show you the way that this can be done. It can either be done in a duct bank, and if you do it in a duct bank, you can get cross sections and encase it in concrete. You can get material takeoffs and on both the concrete and the cable, the conduit and the concrete. But you could also route it through a plenum in a building if you would like by using the same functionality. So that's what I'm going to go ahead and simulate today. We're going to go to a guide conduit, and the choice here is a guide conduit, and I'm going to manually route. Actually, let's auto route this one from pick point, and I want to go to elevation 10 feet. So, and it's going to tell me my direction. If I wanted to go in the Z direction and then the Y direction, and then by default the X direction is the last one left, I could pick route, pick my two start and end points, and it will auto route that conduit for me. We go back to top view, and if I wanted to make a change or two here, I would go to modify and insert a vertices at that point. Then I could pick this vertice and move it over, and then refresh my guide conduit. So once I've got the guide conduit geometry the way I want it, I'll now go to arrange the conduits. Basically, you're building a conduit array. So I'll have to set a retrieval code, and I'll have to set a prefix and a size and type. Now in this case, I can't really do a generic because I'm basically designing a raceway system. So let's pick a 2-inch conduit here. I can always change that. I can always change this value later after I've got all the conduits routed. So these are going to be low voltage power, and I want to center them around the guide conduit. I've got a choice of left and right and up and down, and I want 2 columns and 4 rows. So when I execute, it builds my conduit rack for me. And if I look at this in isometric view, you'll see that that rack of conduit followed my my guide conduit, but it really didn't do it the way I was hoping it would. I made a mistake. It never happens, right? So I can undo the execute, and then I can change it to 4 columns and 2 rows, which is the way we really wanted it done. And it will reroute and revise those just that quickly. Then, of course, I can edit the conduit data in the drawing and get these conduits to actually have the exact naming conventions and service levels that we were looking for. Okay, I got about 5 more minutes, so I want to go to a different project and show you some bulk cable routing. Let's dismiss this form. All this is stored in a database, by the way, so I could retrieve it. I'm not required to save it, because it's being in a database, you always have the ability to retrieve it from the database. Okay. This project was an offshore oil production platform. And offshore projects, the cable tray, the real estate is very valuable. They try to get as much stuff as they possibly can because it's extremely expensive construction. So you inevitably end up with a very busy and very dense raceway system, something like that. Now, one thing that I didn't show you, but I'm going to explain, conduit, a cable tray does not always have to have a fitting. There are cases where you can have a discontinuous tray where a cable can route in this tray and jump out of this tray and jump into that tray without a fitting by being supported in the field. So the program allows you to do this to make a continuous raceway using something called an airway. So that's what these little tubes are in the model. Those are the airways that we would use to identify discontinuous tray that the cable can actually go ahead and route through. Now I'm going to go back to my cool tools and I'm going to show you some of the functionality that we were demonstrating in the last project. I pick Motor Control Center and add all of the cables that are connected to that Motor Control Center. I can show and tag it. That's where it's located in the model. And I can then use my cable query to add all of the equipment, and I can show and tag each location of each end device that one of these cables is routing to from my Motor Control Center. I can then route and show those routes through the raceway system. And of course these routes are in 3D, so you get very accurate cable takeoffs and cable lengths when you use this software. Okay, that's pretty neat. But in real life, I'm dealing with lots of cables. So what I'm going to do is I'm going to call up all of the cables that are in this job. I'm going to query my database and bring them into my user interface. This is called DBView. It's very similar in functionality to Microsoft Excel, and in fact you can copy and paste fields or cells from this back and forth to Excel. So if you've got any information in your Excel file, you can very easily get it into your program without re-entering the data. So I'm going to go ahead and copy all of these cable tags, and I'm going to hit batch route, and I've got some options here, some toggles that I can turn on and off, but I'm just going to take the defaults again for the purpose of this demo. Now, I like to ask people, how long would it take you to route over 500 cables through a raceway system as complex as the one that I just showed you? And the answers vary anywhere from a week to a month. And then I ask them, well, how long would it also take to consider the NEC tray fill and the conduit sizing and do your tray fill calculations and your conduit sizes and do a takeoff on your cables? And their answers are much longer time frame than we just explained. Well, we just routed over 500 cables, and if I go to design reports and get ask for a tray fill report, I can create a report. Now it's going to ask me if I want to resize my cable trays, and I never do this. I always lock my trays, so it really doesn't matter if I say yes or no. But it'll give me a list of every raceway that I have on the job, and it'll tell me the fill percentage and the section of the National Electrical Code that it used to calculate that fill percentage. Now, as I flip through here, you'll notice that none of these trays are filled to more than 80% because I set my spare capacity in the program at 20%. So it'll always, it will not fill more than 80%. This tray, according to the program, is full. As a matter of fact, this is a low voltage tray, and there are two sections of the code that apply to this tray, because I have some cables that are smaller than 4-aught and some that are larger than 4-aught, and there are two different fill requirements in the code to calculate that fill correctly, and the program is capable of handling that. Conduit report, I'm going to query, and I can limit the information that I'm querying in my reports to just conduits that start with a C. And I want to get a list of the cables that are contained in that conduit, and I'm going to go ahead and create that report. In this case, I do want the program to resize my conduits because I want to optimize my my construction. So the first conduit here is C0002. It's 1-inch RGS. There's one cable in that conduit. It is 36% full with a code maximum of 53%. If I scroll down and I find this conduit actually has 3 cables in it, so its maximum by code is 40%. As you change the number of cables that you put in a conduit, it changes the fill percentage that's allowed by code. So this 2.5-inch conduit is 35% full, so it meets the code requirement, and the program is using the minimum size conduit that meets that code. Next one I'll do is a material report on cable, and I'm going to go ahead and create that report. And this is going to give me, it's asking me if I want to refresh my conduit and cable, and I don't, because I just rerouted all these cables, so I know that my data is current and accurate. What this is telling me is that I have a single pair number 16. I've used it 89 times for a total length of 7,700 feet. And you can see all of the cables that are taken off, and that program just routed 66,000 feet of cable and did the cable takeoff. Show you one more thing, and then we're gonna bring this to a close. I'm gonna go to my cable schedule, and this cable schedule is very heavily customized to meet the client's requirements. One of the advantages of the program is it gives you the ability to customize your Excel reports. So in this case, my cable schedule is going to give me my cable number and the from equipment and description and location, the to equipment description and location, the horsepower and kVA for the motor loads and electrical loads, and the voltage for the electrical loads. We're looking at instrument cables, so that's why it's not there right now. It's also going to give me the cable size, the length as it's routed through the raceway, plus the additional route length that I can control in my project setup, and the OD of the cable. It also tells me the cable gland, whether it's a sealing gland or a non-sealing gland, and the multi-cable transit module block that would be required, so we can get a takeoff also on our MCTs. And it gives me the detailed route in the sequence that cable would be installed in the raceway system. So there's all of my cables, and again, it's in an Excel format, and it is completely customizable to meet your client or project or company standards. So with that, I'm going to bring our demo to a close, and thank you for your participation and your patience. And I'm going to go ahead and open this back up to, I'll turn it back over to Rachel to continue with our PowerPoint.
Awesome, thanks, Roy. Well, we don't really have any questions. Oh, hold on, let's see, I've got one. Let's see, Travis Fisher asked, what does the software cost? We can get you guys in touch with your local sales rep to talk about the pricing. I don't have that information here in front of me, so I'm sure your local sales rep will have that info. If you don't know who you should speak to about pricing for this software, send me an email and I will look up your location and direct you to the right person. Does anybody else have any other questions? That's all I've got.
Well, that's great. That means that we must have either done a very good
Hold
job.
on. They're starting to filter in. We've got one more.
As soon as I started to say we did a good job of explaining it, that's when the questions are going to roll in, isn't
it? They're rolling in. Let's see. Todd asked, with the conduit modeling, will the program use the correct conduit radii?
Yes, it will. The program, especially if you use Revit, you can use Revit conduits and you can define the radius. Or if you're going to use the program, you can set the radius of the conduits. I know it looked like they were all hard corners, and it did not graphically represent correctly in my demo because I didn't set the parameters correctly before I started.
Awesome. Next question. You are modeling aluminum cable tray. Can you use any other material such as fiberglass or stainless steel?
Yes, you can. The first model that I showed was aluminum B-line cable tray. That's the spec on that particular project. The second one that I showed you was actually Enduro fiberglass tray. And I've also done stainless steel. We used Oglen stainless steel and also Van Trunk stainless steel cable trays on various projects. I've also used P&W and T&B. So it's very easy to change your tray spec. Basically, we're going to give you lots of the B-line catalog, and that's very easy to cross-reference to any other manufacturer or material.
Can you use any other cable manufacturer other than Southwire?
Wow, great question. Southwire cable specs come with the program for free, and there's some other capabilities that are Southwire specific and proprietary, like their pull tension calculator and sidewall pressure on their conduit. So the Southwire cable spec is provided with the software, but you can use, and I have used, other cable manufacturers. What you would do is get their catalog information, and you would enter their cable specs in your lookup table in the database, and once you've done it, then you can save that and use it over and over from project to project. This is not something that you would need to do each and every time. Once you've got it in your database and it's checked and you know you got good data, you can use the history to continue to use those specifications on future projects.
Awesome. And does a third party need any special software to view tray and conduit?
No, they don't. When you create these models, you are actually, even though we were working in an AutoCAD environment or in a Revit environment, the information is stored in the database. This database is driving deliverables. If it's an AutoCAD model or a Revit model, once those components are created in that CAD platform, you can save those as standalone documents, and you can issue them to your client or put them in your document control system or handle your deliverable of electronic media exactly the way you do today, and those files can be opened and edited and printed without the database software.
Awesome. Does this system work with conduit instead of tray?
Absolutely. We did demonstrate a little bit of conduit. I know that a lot of the commercial folks don't use a whole lot of cable tray, and we have some very good tools for routing conduit, auto routing conduit, and you know, as we discussed, we can take off, we can do a conduit takeoff and a conduit schedule very similar to the cable schedule and the tray schedule that I showed you.
And the last question I've got so far, does this work with Fabrication CAD MEP?
Mike, you want to jump in there? I'm not personally familiar with MEP. If it's an AutoCAD based product, then it shouldn't be a problem. But I'm going to ask Mike to go ahead and help me out on that one.
Sure. Hey guys. I mean, technically it does work with CAD MEP. It's not using the same fab parts that you're used to using in CAD MEP, but we can pull this into. It's just an AutoCAD file, so it's bringing AutoCAD information, but it's not using the CAD MEP parts.
And to be clear, we are talking about the fabrication CAD MEP, which is different from AutoCAD MEP, correct?
Correct. Yes.
Okay. Awesome. All right. Well, that's all the questions I've got. Those are some fantastic questions, guys. And as promised, we have a gift card to give away. Let's see. Doug Williams, are you still on the line? If you could, type me a little message in chat and let me know that you're here. There you are. Thanks, Doug. All right, congratulations. Our marketing team will reach out to you soon about your $25 gift card. And that's all we've got for you guys today. Thank you so much for joining us. We hope you found this webinar informative and helpful to your business. And we look forward to seeing you guys on a future webinar. Thank you so much.